Howdy guys. I'm not sure about the background noise, but today wasn't a day I was going to record a video because of this background noise, but it's okay. I have to maintain the consistency and I'm just trying. So let's see if this works or not. And today's video is going to be a bit different because in today's video I'm going to do a live solution and I might just fail because I haven't tried it yet. I take about an hour or so while doing these questions, and we have game 3 here. Oh no. What I want to do first is I want to solve game 1 and 2, and after that only will I be solving game 3, because most of the time they are like an easy solution, optimized one, and the best one. So let's see if this is the case or not, but it'll be fun solving this question. An array of non-negative integers, you are okay. So here we have an array of non-negative integers and we are at the start, and now what we want to do is we want to jump and reach at the end of the array, and we need to check if the end of the array is reachable or not. And what we can jump is we can jump the maximum, that is the element present in that array. So let's see for 0, if it's present 2, we can only take 2 jumps from here. The background noise wasn't enough that people have brought their car in to just honk. Okay, so I need to reach at 4 and I am starting. So what I need to do is I need to, let's see, if I jump twice here I would reach 1, 1, okay, this is reachable. If I jump 1 then 3, okay, this is done. If I jump 3 I will 1, 2, 3 at 0, okay, not done. If I jump 2 it will be 0, 1, 1, okay, not done. Okay, so this one is this is the only solution. I mean, this is one of the solution where we need to return false, and this one is the solution where we need to return false. True, because if I jump 1 and take a jump, then it's true. If I jump 1 and again I jump 1, it's true in all the cases. So in these kind of questions where you have to read somewhere, why not start from somewhere? So let's take an integer that is last, I'll name it last position, and okay, and what I'll do is I'll mark it 0 right now. Not 0, sorry, I'll mark it the end position. So I need to reach, I'll explain you in a second what I want to do. Okay, so if you would look here, we have an array of 2, 3, 1, 1 and 4. So what I am going to do is I am going to check this array, the array that contains only 4, and I am going to check if I can reach the end or not. Of course I can, because I am at the end. I don't need to do anything. Then I'll check the array 1, 4, and I'll check if I can, starting from 1 I can reach to 4. I can, okay, this is true. Then what I will do, I will check array 1, 1 and 4, and this time I won't include 4 because I know I can reach to 4 from 1, and from this I can reach to this easily. So what I'll do is I'll just check if I can reach this, the second last element from the third last element, and so on, the third last element from the second element and the second element from the first element. If I can reach these elements anyhow, then my solution is done. Okay, so what I'll be doing is I'll start a for loop with my first element as the last element of the array. I'm bad with spellings, guys. Oh, what is happening? I can't seem to find that G. Okay, so it must be greater than or equal to 0, and then I plus plus. Then what I need to do is I need to update, I have my last position, and what I need to do is if I need to update my last position. So if I is greater than or equal to the last position. What does it mean? That if it is greater than or equal to the difference between the last position and the I can easily, I mean, for this I have to reach only one, and if it is, I am tired. Okay, wait, my logic's a bit wrong. What I need to do here is, if I is, if the element at I, I'm so sorry, if the element of I at I is less than the difference between the last position and I, then I can easily reach it. Greater than the last position, in this case it is, let's do last position minus I, and let's check if it works or not. I'm not sure. Then the last position needs to become I, and then after this for loop I'll return if last position is equals to 0, because at the end, if this all works out, we need to reach at 0. I hope it works, because I'm not so confident about this condition. And my spellings too, I'm so sorry about them. And I don't know, oh shit, like really bad at that. I tend to misspell a lot, and I am reaching out of bound for this array. Why am I out of bound for this? I'm starting at this. Oh, how could I do this? It's basic mistake. I started from the end and I incremented. It's accepted. Let's just submit and see if we find some test cases which I'm not able to. It's done, and it's 81% faster than the other solutions. Okay, let's jump to game 2. Okay, now we are again given an array as expected. Each element in the array represents a maximum. Okay, your goal is to reach the index. So in this case we have a limit, and we need to jump more than that. So we can't start from the end. We need to think of something different. Why not the first example is same? So I have two ways. I can jump to 2 and then 1 1 and 4. This will require me 3 jumps. If I jump 1, then this will require me 2 jumps. So I need to do this. And how do I do that? I'll first start at this index, and then I'll check if all the index between this and, okay, let's call this position. Okay, I'll just do it here. 2 3 1 1 and 4. Okay, let's call this index the position right now. And what I want to do is, I have a destiny, and the destiny is equal to position plus nums of that position. Okay, and now what I want to do is, I want to check if the I want to calculate the destination first. Okay, so this is the destination, this is the position, and this is the destination. So position right now is 0, and 0 plus 2 gives me 1, and gives me 1 and 2 here, this. So what I need to do now is, I need to check for all the variables in between. I mean, if I can do this, I can go here and I can jump 1 and 1 and 4. Each goal you can be okay, so we don't need to include the last case, the last question, because in this question it is clearly stated that we can there is a shot that we'll always reach the last index. We just need to find the minimum jumps that we need to take. So what my plan is, I'll check this as well as this. So whoever is greatest, let's say 3 is in this case 3 is greater than 1, so I'll not take 1 as my position, I'll update 3 as my position, and then I'll again do the same thing. And when I update my position to 3, my destination would, so okay, let's take an integer, it is 0, then I'll take an integer position, let's just call it pause if so I can avoid a million mistakes, and then I'll call it a destination, and then I'll, okay, so now what I'm doing is I'm iterating from 0 to length. Okay, wait, do I need to check for the last index? If I'm at the last index, I don't need to calculate the jump for this index, so I'll be iterating 1 less than that, then okay, plus plus here, not minus minus. Then now what do I need to do in this for loop? I have the position, I need to calculate the destination, and destination would be of course the maximum of either position plus nums of I, like I told, either it is going to be this, or either it is going to be the current destination that I am on right now. So for example, if this was 3, so I could have jumped here, but right now what I am doing is I am also calculating for this as well as this. So for this I still want to keep the destination as this, and it should not update or harm my destination. So I'll keep destination equal to this, and or des. So whatever is greatest, my destination will be equal to this. So right now I'm on 0th index. So let's say if position equals to 0, let's just say that. What I need to do then I need to update my destination. First I need to jump. For sure that at the first I need to jump. Then if I'm on this, I need to update my destination equals to position plus nums of I. So clear. Okay, and no, I need to update my position to be equal to destination. I updated my sorry, I forgot that I updated my destination above this code. Now I need to update my position. So if my position is equal to 0, then my position after this should be equal to destination. Okay, so if I am at 0, what I am doing is I'm calculating a destination, and also what I am doing is I am updating my position to be equal to that destination. So where did I calculate this? While the loop is running, this won't be done, but destination will still be calculated. So for this case I am just doing a dry run. Now at the end I want to return jump. That's it. Okay, so let's do a dry run, and this will be, of course this needs to be dealt with, and we'll deal with it in a minute. So let's start with the dry run. I'm at 0th position. Now what I do is, according to this code, I calculate the destination at I equals to 0, my pos equals to 0, and my destination is equal to, I calculated it and it would be 2. Now what I would do is I would check if this is equal to 0. Okay, here we get it. If I don't need to do this, I can simply write here I. If position is equal to I, then this would be fine. If position is equal to I, what do I need to do is I need to update my position. Okay, so not in leaving that I am updating my position to be equal to destination, and in this case it would be 3, and then I'm incrementing the jump, and then at I equals to 1, what I have now is I have a new position at I equals to 1, and my position, let's not write everything again, let's just update it. Okay, for I equals to 1 my position is now 2, so I need to calculate the destination at 2 here. For now I equals to 1, so the destination would be max of the previous destination or the new destination. So my position is 2 and my num is 3. Wait, there's a slight bit of issue there. I think I should do this. Okay, so now my position is 1 and it is 4, and I know that I think it should work right now. Let's just see if it does not work for this. I'll go through my, oh I'm so sorry, this always happens. Let's do this. Yeah, so it works. Now let's get back to our dry run, and what we were doing is we were checking if the destination, the new destination or the destination we are calculating is greater than the destination of the previous destination or not. In this case it is clearly then, but what in this case I is equal to 1 and position is equal to 2, so we won't go into this loop. We'll wait till I is equal to 2. So when our position is now at position is still at 2 but our destination is 4, it has been updated. So now at I equals to 2 our position is still 2 and our destination is still 4, because after upgrading we checked here and it would give us 3 but we actually got 4. So now what we are going to do is 0 1 2 3 4, okay 4. So what we are going to do here now is we get here and we update our position, and this way it will be 4, and we also take one another jump. Now we'll go to, we can actually, it won't be such an issue, but let's just say this is equals to nums dot length minus 1. If we find that position right now, we can stop the loop. I mean, there's no need to go again checking for these, because we have find the minimal with the of course these are a big issue, so we don't need to do that. We have find the minimum problem. I hope this video is not getting too long, and I'm just going to submit this problem and let's see if it works or not. It works and it is faster than 50% of the codes. Okay, so problem 1 and 2 are done. We are back again at problem 3, finally today's problem. So what do we have here? We have an array here again, as it was mentioned. Okay, this is, I think this is a slightly different problem. Here we are given an array of non-negative integers and we are also given a start position, so it is not 0 anymore. Now what we want, we can, okay, we can jump in both direction, left or right. Okay, so I think this is similar to the knight and the chess problem, and I hope I can solve this problem. So let me first explain you how am I going to solve this problem with this first example here. Okay, so my starting position is 5, so I can 0 1 2 3 4 5. I am at 3. So now at 3 what I have 2 positions that I can go on. From 3 I can go to, okay, let me write it in a better way. It is 4 tap tap, 2 tap tap, 3 tap tap, 0 tap tap, 3 tap tap, 1 tap tap, 2. Okay, so right now I am at 3. Now where can I go using this 3? I can I jump to 1 or Okay, so I can only jump to this plus 3. So I can go to 8 from here. So 8 would be somewhere here where we don't care about it. And I can go to 5 minus 3, that is 2. This I can go to here. 3 minus 3 I can go to here. I don't know what's happening. Okay, here. So now what I have, see, if you can look, it is like a binary tree now. It is 3 and I have its left, its left child. Okay, I'm not so good at this. Let's just open up the paint and not waste our times, and I can maybe explain you the problem. Left 4, it is 4 2 3 0 1 3 2. Okay, so those who are wondering, is my handwriting really like this in real life? Yes, it is. I'm just kidding. Okay, so now what I am at this position. I think I left an element. After one there is a 2. After one there is a 2. Okay, I'm at this position. I calculate its right child and a left child. So its right child is out of bounds, so I don't care, but its left child is 3, which is totally inbound. So I go to its left child and then I calculate its right child and the left child. How am I calculating the left child or the left child? For right child, all I'm doing is I plus nums of I. Yeah, in Chinese though. I plus nums of I, and then I get this, and then I get that. So now what I'll be doing is, instead of doing this, I think I better be writing the code. And now few observations. We can't split the number. Like if 3 was given to us, we can't like split it to 1 zeros and 2s and take that many jumps. We have to take a jump for 3. So again, I'll be starting with a queue of integers, and I'll be taking as a, although stack is faster, but I think I'll stick to q, and I'll be naming it QUV, who does not, and then it will be a new linked list. Now what I'll be doing is, I'll be adding the element to the queue, adding the first element, adding the start element to the queue. I have a start, so the array of start should be added to the queue. Now okay, now what I want to do is, while the queue is not empty, what I'll do is, I'll check for a few things. That I'll calculate the left child and the right child. So let's do it int left equals to, I need to get the starting position. Okay, then I need to subtract the array dot start from it. Okay, now what I want to do is, for int right, I need to do the same. I just need to add the starting position. Okay, let's also do this one thing. I want to pop the first element, so I can store it, let's say somewhere, and any integer called then I store this dot remove last element. Okay, so I calculated its left child as well as the right child for this. I think I'm missing something, guys, and I'm not sure what I'm missing. So now what to calculate the left or the right child, I need to know the index of this. So I think it's better if I store the index and not the value. Okay. So now my int, let's say index is equals to q dot remove. I hope I am writing this correctly, because I'm not so familiar with using the collections. I've just started using these collections. Before that I was on C++ and I'm switching to Java right now. Okay, so in this queue what I need to do is, using this index I need to calculate a int left and a int right. Okay, so how do I calculate this? I need to add this index to the value at that index. Cool. Now what I need to do, I need to subtract it for the left and I need to add it for the right. Oof. Doing 3 questions in a row is hideous. I mean, it can actually get to you. Okay, now I need to check if my left is valid or not. So left must be greater than or equal to 0. If it is anything less than 0, it is out of bound in this direction. And I need to check for one more thing. If the value of my I need to check if it should not be less than 0, and thus I think it will work. Now what I want to do is, and one more thing, that it is not equals to 0 and the array at left, because if the left is equals to 0, then I'm at my solution, because here what we need to do is we need to reach the index with value 0. Okay, so this, and now what I need to do is I need to add this to the queue left, and same for the right. I need to check these 2 conditions. I'll simply add right here and also here, RGHT, and also here. I should have wrote the whole sentence again, but yeah, it's okay. It should be less than or equal to, no, just less than nums dot length, not nums. In this case we are given an array. Okay, try to ignore the background noise, guys. You can, if I can, I'm not sure. If you want to quit, you can just leave the video. I'm almost done. Basically after doing this I won't be explaining the code much, so if you want you can leave. So we were here and we added these both. Now what we want to do is we want to return true somewhere, right? We want to return, okay, instead of thinking of returning false, instead of thinking of returning true, we can return false in some case, right? Okay, let's remove this from here. I'm getting confused, guys. And also this. Okay, so we have checked for the bound, and what else do we need to check for? 0, I think so. And we can do one more thing here is, if left, if array at left is equals 0, return true. And where do we return false if this condition is not met once, we can return false after the while loop. Where is the while loop? Here. If the while loop ends, we can return false. Okay, here we are. Let's go back to this example. Okay, here is another issue, that it might just happen that if the array was whole 111, I would, let me do this here. If my array was 11111, not 11, 1, then if I start at this, I would go to this and I would go to this, and then what happens is when I go to this, I'll go back to the start and it might become a loop. So I need to check if I have visited that element previously or not. So let's quickly do that, guys. I'll simply create an array of integers. Let's call it scene, and the size of the array would be same as the size of this array. Now what I'll be doing is I'll be marking them scene here. Scene of left equals to 1, that means I've seen it, and same here, scene of right equals to right equals to 1. So, and I also need to check for this condition, and if scene of left is equals to 0, then only you need to enter this, and same for here. If the scene of right is equals to 0, okay, done. Okay, I've written true, I've written false, I've done with scene, calculating the left as well as the right index. I'm removing the first and then I'll adding. I hope it works. Let's just see. I'm not so sure because I think I'm missing something. What's the issue here? Other than my spellings, I think there's issue for parenthesis there, and then for my spelling, where was I? Here. There we go. Any other problems? Okay, also this. No. This and this. Done. Any other problems? Why am I going to index -1? If this is greater than this, then okay, if it is checking here also. So let's add one more thing, and index I need to go in this loop. Okay, let's do one more thing, and let's just add that if the value at that index is 0, then we can not go here, not go in this loop. So if value of right, or in this case left, I've just written it, so I'll copy it to keep it low. Is not equal to 0, and I'll be doing the same for you, that it should not be equal to 0. now what I want to do here is I also want to check and this condition. This should be, and these two conditions should be met, that left and right should be less than the values. I don't know how I didn't get that value. So if these two are true, then only return true. So if this is false, okay, I need to do this first. So you know, if in end what happens if the first case is false, it does not check for the second case. So this way I won't be visiting this, and hence I won't be checking it. If these both are true, or right is less than nonce dot length, and then this. So let's see if we have encountered all the difficulties here. Sorry. See, in previous two versions the array's name was nums, and in this question the array's name is array. So that's the, why is it still visiting there? I don't understand. If it is greater than 0, then only you must check for this condition, and in also this, if it is greater than 0, and for the index I'm just calculating the index. Okay, I'm okay. For the scene of left is also, it's also done. Maybe here it is the issue. In which line? Okay, in line 16. In line 16 here, the issue is here, that I am getting a negative value. I am getting the value of -1 for this. Maybe right is equal to -1. How is it possible that my right becomes -1? I'm so sorry guys. Now I hope it works. I did this silly mistake. I just copied and pasted the thing from the above, and man, it's so embarrassing. Instead of using a minus sign, I used a plus sign, and I could not have guessed that. What was my mistake if all this didn't happen? Okay, so it's submitted. Let's check details here. Woof, and I'll try to explain the code if you are here. Yeah, it beats 100% of the runtime solutions, so it's good. And yeah, this could be this is backtracking solution. This takes a huge amount of time, and this solution, I don't know this solution, but yeah, I'll check for more such solutions. Yeah, it is similar kind of. Yeah, it is the similar solution kind of. Okay, so guys, if you want to know the code, it is there. I don't think that I'll be able to explain you in a short while, but I'll try. So we are doing a BFS search here, breadth first search here, using a queue. Why a breadth first search, or why is it a tree? It is a tree because it has a left child and a right child. What is its left child? Its left child is the destination that it can reach if it jumps left, and its right child is the destination that it can reach if it jumps right. So for each node, each root node, we are calculating its left and right and left and right, and checking if the left child or a right child is equals to 0. If any one of them is equals to 0, we are done, we have the answer. If none of them is equals to 0, false. Now why we need this scene array? Because it might just happen that the left child may point to the right child. The parent's left child may have the parent as its left or a right child. So this might be an issue, that where you will just keep on going round and round and round about 2 or 3 elements only. As I gave you an example of 1 and 1. And I'm starting at this one. So what is my left child? It is this one. What is my right child? It is this one. Okay, I get here. My left child, there is no left child. My right child is this, and my right for this my right child is nothing, but my left child is this. And now again I have to calculate for this, and then a loop starts. So that's why you need a scene array, that if you have already visited that index and calculated its left or right child, or if you have visited that index while calculating while it was a root child, you don't need to do it again. And this was a good question. I don't know the level of this question was, but it was okay.